Now let us consider any vector a bar. A bar is a vector. Okay. So now can you tell me how many ways we can multiply any vector? If you observe this one, any vector can be multiplied in three different ways. First one, a scalar and a vector can be directly multiplied. Okay. C is some constant, a bar is a vector. Just like example, we can multiply 5 into a bar. 5 is some constant, okay, or scalar. A scalar and vector can be directly multiplied. Okay. So a bar can be directly multiplied with some scalar. Is the first way to multiply a vector. And we can multiply vector a bar with another vector in two different ways. So a bar can be multiplied with another vector b bar with the help of dot product. Okay. And similarly, the same vector a bar can be multiplied with another vector with the help of cross product. Okay. So now if you observe here, the vector a bar can be multiplied in three different ways. We can directly multiply with a scalar, and you can multiply with another vector using dot product. We can multiply with another vector using cross product. Okay. These are the different ways to multiply a vector a bar. Similarly, you consider del operator. So del operator is also a vector quantity. What are the different ways to multiply this vector? This is del is a vector quantity, and first thing you said, we can multiply any vector and scalar directly. So this is called as a gradient operation, gradient of a scalar. And next one is we can multiply this del vector with any other vector with the help of dot product. So this del dot, combination of del dot is called as a divergence. Divergence. Next one. Third way of multiplying this del vector is the del can be multiplied with any other vector with the help of cross product. Now the combination of this del cross is called as a curl operation. Curl operation. Now if you just observe this one, so what is meant by this gradient, divergence and curl operation means there are different ways of multiplying del vector. Okay. If you multiply del vector in three different ways, it is going to result a gradient operation, divergence operation and curl operation. Okay. And already we have discussed about del. Del operator is a vector quantity, and also it is a spatial differentiation. Spatial differentiation. Then what about this divergence, gradient and curl operation? So these operations are also called as spatial differentiations. Okay. So these all the three operations also comes under spatial differentiation. Spatial differentiation. Okay. So now we are going to discuss about each of these spatial differentiation in detail. What is meant by gradient operation? What is a physical interpretation of this gradient operation? Okay. And what is meant by divergence and its a physical interpretation? And what is meant by curl and what is its a physical interpretation? Okay. So let us see all these three basic vector differentiations one by one. First, let us consider gradient. First one is gradient operation. Yeah. So just you see here how we have defined gradient. The gradient is nothing but the multiplication of a del vector and any scalar field here. Okay. So let us consider this del vector multiplied with any scalar field. Scalar field. Okay. Scalar field. Okay. Now here let us consider a scalar field temperature. Temperature is a scalar field. I consider temperature is T. Okay. So here, you know, equation for del operator. Equation of del operator is dou by dou x into x cap plus dou by dou y into a y cap plus dou by dou z into a z cap, which is multiplied with t. So then perform a complete multiplication. So you get gradient of t is equal to dou by dou x of t into x cap plus dou by dou y of t into a y cap plus dou by dou z of t into a z cap. Okay. Now this is the mathematical formula for the gradient of t. Okay. So gradient of some scalar t is given by this equation, or this is the formula for gradient operation. Okay. Here you have to notice an important point here. You know that here we have applied a gradient on which quantity? Scalar. Gradient is applicable only on scalar fields. Okay. And what is this results? These results is a vector or scalar. Okay. Here these results contains ax cap, ay cap, az cap. So these ax cap, ay cap, az cap represents direction. Whenever any quantity or any equation contains direction, that should be called as a vector quantity. Okay. That means here what you can understand here is this gradient operation is applicable only on scalar fields. And what is the results? Results is a vector field, or it is a vector quantity. Okay. Or you can directly say from basic mathematics, when we multiply a vector and scalar, results is a vector, or we can say gradient is applicable only on scalars and results is a vector. Okay. So this is the basic information about the gradient operation. Next we will see what is the physical meaning of gradient operation. That means when we apply this mathematical formula gradient operation on any physical quantity, what we are going to obtain. Okay. What these results of gradient gives us. Okay. That is very important to understand. Or why we are going here, I am going to explain you about. So what is the necessity of gradient operation in electromagnetic fields? Okay. Or with the help of this gradient operation, what we can do in the electromagnetic fields, that is what I am going to explain about. Okay. This is very, very important concept. We will see what is the physical interpretation of gradient now. Okay. Gradient. So let us see what is the physical interpretation of this gradient operation. For that, first let us consider coordinate axis. Is the coordinate axis I consider 3-dimensional. Here we have 3 coordinate axes: x axis, y axis and z axis. The intersection of all these 3 axes is origin. Now here I consider this xy axis, the combination of this x and y will form a plane. So this plane is called xy plane, is called as xy plane. Or you can observe that this xy plane will cut the z axis exactly at 0. This xy plane will cut the z axis at 0. That is why it is also named as z is equal to 0 plane. Z is equal to 0 plane. Okay. Now I consider this bottom plane or xy plane or z is equal to 0 plane. I consider this one as a earth surface. Earth surface. I assume the earth surface will coincide with this xy plane. Okay. Now if you just see here, so I consider on earth surface we have some temperature. I consider this is T is equal to 30 degrees Celsius. Okay. That is on this earth surface. And you know that as height increases from the surface of the earth, what happens for temperature? Temperature will decrease. Temperature will decrease as height increases from the surface of the earth. Okay. So I am going to consider another layer or another plane at some height from the surface of the earth. This is another surface. Okay. So, height increases from the earth surface to this plane. When height increases, temperature will decrease. For suppose I consider here temperature is 29 degrees Celsius. Okay. Similarly, I consider another parallel plane at some other height where temperature is 28 degrees Celsius. Okay. So, simply what I mean to say here is, so here on the earth surface temperature is 30 degrees Celsius. As height is increasing, the temperature is going to decrease. Okay. So, here let us make an assumption that the total temperature in this region or on the surface of the earth is represented with some mathematical equation T. Okay. So, now I am going to apply gradient operation on this T here. Consider gradient of T. So, what is the equation for gradient of T? You know that dou by dou x. You know that gradient of T is given by dou by dou x of T into x cap plus dou by dou of T into ay cap plus dou by dou z of T into az cap. This is the formula for gradient of temperature T. Okay. Now, just see here. So, dou by dou x of T finds us rate of change in temperature T with respect to x. Okay. That means this explains how temperature T changes with respect to x. Okay. So, just observe here, come to this diagram. Whenever I increase x value like this, okay. So, when x value is increasing, what is happening for height? Height from the surface of the earth. So, when we move along the x axis or whenever x value increases, height do not change. Height is a constant. When height is constant, what happens for temperature? Temperature is also constant. Okay. When temperature is constant, then what happens for dou by dou x of T? Which will become 0. Okay. That means it means that the temperature do not change along x or temperature do not change with respect to x is the first term plus second term. Consider dou by dou y of T. Here rate of change in temperature T with respect to y or how temperature changes with respect to y here. Okay. Similarly, here you consider whenever we increase y values or change the y values, what happens for height? Height from the surface of the earth do not change. So, if we move along y axis, height do not change, height will remain constant. When height remains constant, temperature also remains constant. When temperature remains constant along y, then what is the dou by dou y of T? Will become 0. Okay. So, second term is also 0. Now, let us observe the third term. Okay. So, in the third term, we can observe it is a rate of change with respect to z. When z value increases, what is happening for height? Okay. So, when z value is increasing, the height is also increasing. Okay. When height increases, what happens for temperature? Temperature is decreasing. Okay. So, simply temperature changes with height or temperature changes with z coordinate. Okay. So, whenever temperature changes with respect to z or along z axis, this term is a non-zero term. This is a non-zero term. Okay. So, we do not know exact value. So, let us consider the gradient of T will become dou by dou z of T into az cap for this example. Okay. So, if you observe this one, you know that T is a scalar, del is a vector, vector into scalar is a vector again. Okay. So, this quantity is a vector quantity. Temperature is a scalar, but gradient of T is a vector. Now, every vector should have magnitude and also direction. Okay. You know that az cap indicates direction. Okay. and dou by dou z of t indicates magnitude. Indicates magnitude. Okay. So that means what is this? This is the magnitude of gradient of t. This is direction of gradient of t. We say clearly direction of gradient of t. Okay. So now here I would like to concentrate on what is the direction of temperature or direction of t here. Okay. From this equation, direction of gradient of t, this is required. This is equal to gradient of t divided by magnitude of gradient of t. Okay. This dou by dou z of t is nothing but magnitude of gradient of t. Okay. So this is the equation. So here, what is the direction of gradient of t? In this example, we obtained direction of gradient of t is nothing but Az cap. Okay. So Az cap is given by gradient of t divided by its magnitude. Okay. Now just see here. So here from the same equation, here come to this diagram. Can you tell me what is the direction of this plane? So this entire plane or area of this plane is showing upward direction or downward direction. Okay. Or this area is showing in the upward direction or downward direction. So I can say that the upward direction of this surface or this surface area is Az cap direction, because upward direction is z direction. Z direction is denoted with Az cap, which is perpendicular to this surface. Okay. And what is the direction of this surface? Its area is also showing upward direction. Upward direction is Az cap. Again, this surface area is also showing vertically upward. Vertical upward direction is Az cap. This direction is perpendicular to this surface. Okay. Everywhere what you can observe here is, so direction of all these surfaces are Az cap direction. Okay. So what are these all these surfaces? All these surfaces are combinedly can be called as t is equal to constant planes. T is equal to constant planes. Why? Because here it is that plane where t is equal to 30, some constant. This is the plane where t is equal to 29, constant. This is the plane where t is equal to 28, it is a constant. Okay. Everywhere we have t is equal to some constant. T is equal to some constant. So all these planes are combined called as t is equal to constant planes. Okay. Then what is Az cap? How this Az cap is related to this t is equal to constant planes? So we say that Az cap is nothing but unit vector or direction normal to t is equal to constant planes. Or we say that Az cap is the direction of t is equal to constant planes. T is equal to constant planes. Okay. So now I am going to write what is Az cap from this diagram. From the diagram we say that Az cap is nothing but direction of t is equal to constant planes, or we say that unit vector normal to t is equal to constant planes. Unit vector normal to t is equal to constant planes. Now this is what you need to understand here, very important concept. Whenever you want to find the direction of some t is equal to constant planes, what do you need to find? You need to find gradient direction, gradient of t direction actually. Okay. So this is the important application of the gradient operation, very important application of gradient operation. Okay. Whenever you want to find the direction of any plane or any surface, okay, whenever surface is represented like a t is equal to constant plane or t is equal to constant surface, okay, then just you need to find the direction of gradient of t to find its direction, or plane direction or surface direction, okay. So, this is the one of the important application of gradient of t. This is the way how we are going to use gradient in electromagnetic fields. In electromagnetic fields, when we study about boundary conditions, we need to know what is the direction of each boundary or surface, okay. So, boundary direction or surface direction or plane direction is calculated with the help of the direction operation, or by finding the direction of gradient of t will give you the direction of t is equal to constant surface, t is equal to constant surface, okay. Now, I will give you concluding point. You can take it as a note. So, what we have studied till now is, whenever we have a plane, this is the plane which is called as f is equal to constant plane, f is equal to constant plane, okay. Then if you want to find its direction, what is the direction of this f is equal to constant plane? So, always the plane direction is a perpendicular to its area or perpendicular to its surface, okay. So, this is a n cap is the direction of this plane. So, this direction of this plane is given by gradient of f by magnitude of gradient of f, okay. So, this is a very important point. This is the way for all f is equal to constant planes, we can find out the direction of the plane with the application of gradient operation, okay. That is gradient f by magnitude of gradient f, okay. So, let me explain with an example here. I will consider an example. Let us consider an equipotential surface, an equipotential surface V is equal to, or V of x comma y comma z is equal to x minus 2y plus 3z is equal to 5 volts, 5 volts, okay. Then find the direction of V is equal to phi surface. Then find what is the direction of this V is equal to phi surface, okay, where phi is a constant, V is a potential field, okay. So, to find this one, what is the formula we have? We need to use the gradient operation, okay. So, direction of this V is equal to constant plane is given by gradient of V divided by magnitude of gradient of V, okay. So, now let us find out first what is gradient of V, then we can find out its magnitude, then we can easily say what is the direction of V is equal to constant plane or V is equal to constant surface, okay. So, we will say the formula for gradient of V is given by dou by dou x of V into x cap plus dou by dou y of V into a y cap plus dou by dou z of V into a z cap. This is the gradient formula, okay. Now, we know the equation for V. Equation for V is nothing but x minus 2y plus 3z. This is the equation, okay. Let us substitute this equation in this formula. Then we will have dou by dou x, V is nothing but x minus 2y plus 3z into x cap plus dou by dou y into x minus 2y plus 3z into ay cap plus dou by dou z of x minus 2y plus 3z into az cap, okay. Now, let us evaluate this equation. So, I say here, here I write the gradient of V is equal to, here I can understand, here all the differentiations are partial differentiation, That means dou by dou x differentiates only x term, dou by dou y can differentiate only y term, and dou by dou z can differentiate only z term. Remaining terms are nothing but constants for that differentiation. Okay. So, then it will be gradient of v is nothing but, so what is the differentiation of x? You will get 1 into x cap. What is the differentiation of minus 2y here? Minus 2 into ay cap. And what is the differentiation with respect to z here for 3y? We get 3 into az cap. Okay. This is what the gradient of v is. Now, let us find what is the magnitude of gradient of v. Okay. Then it is the square root of this x component square 1 square and this y component square minus 2 square and this z component square, that is 3 square. Okay. So, which is equal to square root of 14. This is a magnitude of gradient of v. Now, let us find finally what is the direction of v is equal to constant plane or surface. A n cap is gradient of v by magnitude of gradient of v, that is ax cap minus 2 ay cap plus 3 az cap divided by square root of 14. Okay. So, this is the answer. So, this is the direction of v is equal to constant surface or given equipotential surface. Okay. So, this is the very important application of gradient here. This is the way how you can find out the plane direction or surface direction if it is in the form of v is equal to constant. Okay. Now, just we have studied about what is the application of gradient or how we use gradient operation in electromagnetic fields. Okay. So, here I need to tell you one more important point about gradient. Earlier we have considered the example for gradient operation, and I consider the coordinate axis x, y, z, and I consider the plane xy plane as a earth surface. So, and I said that as the height increases from the surface of the earth, the temperature is going to decrease. Okay. So, now I am going to consider 3 different paths. One path is parallel to this xy plane or earth surface, and another one is inclined and as shown in the path 2, and vertically upward path, third one. Now, observe these 3 different paths. So, when we move along which path, the change in temperature is maximum. Okay. So, now observe this one. If you move along path 1, if you move along this path 1, okay, does the height from the surface of the earth changes or not? Here you can observe height does not change. Height does not change from the surface of the earth if you move along path 1. When height do not change, temperature also do not change. Temperature is constant. Okay. Then what happens? The temperature along the path 1 is a constant. So, its a differentiation or gradient is 0. Gradient of T is 0. Okay. Similarly, if you move along the path 2, does the height changes or not? Yes, absolutely. So, when you move along this path, height is changing. Height is changing. So, when height changes, temperature also changes. Temperature also changes. When temperature changes, gradient of T may not be equal to 0. Okay. So, it is non-zero term. Gradient of T is non-zero term. And similarly, if you move along path 3, along the path 3, if you observe, again height is going to increase. H changes. So, temperature also changes. Okay. So, then gradient of T is non-zero along this path. Okay. So now what I require is along the, if you compare along path 1, along path 2 and along path 3. Okay. Along which path the change in temperature is maximum. Okay. So usually when you move along path 2, so when you travel long distances, the small height will be covered. Small heights will be covered. Okay. So change in temperature is small. Change in temperature is small. Here temperature do not change. Here temperature change is small. But in this case, when you move along the path 3, so temperature height changes maximum. So temperature changes maximum. Okay. So T changes maximum along vertically upward direction. Vertically upward direction is nothing but z-axis direction or az cap. Okay. So from this diagram we can say that, from this concept we conclude that maximum temperature changes along z direction. Okay. What is z direction? Already we have proved that. We have proved that z direction is nothing but gradient direction. Is nothing but a gradient direction. Okay. So now I am going to conclude that when do you find the gradient direction? Az cap. So gradient direction is always gives us maximum rate of change in temperature T. Maximum rate of change direction in temperature T. Okay. So finally I am going to conclude here. You can take it as a note. You can take it as a note. So what is the gradient of T explains? Gradient of T is a vector quantity. Vector quantity. Vector should have magnitude and also direction. Direction. What does the magnitude of gradient finds? The magnitude, if you apply the gradient operation on temperature, its magnitude gives us rate of change in temperature T. It gives us rate of change in temperature T. But what does the gradient direction gives us? The gradient direction gives us the maximum rate of change direction. The gradient direction is nothing but maximum rate of change direction of temperature T. That means in which direction temperature changes maximum, that is the direction of the gradient. Okay. So this is the second important point. Here we can say with the help of gradient direction, we are going to find out 2 points. Okay. So gradient direction is always maximum rate of change direction of temperature T. Also gradient direction gives us the direction of T is equal to constant plane. These are the 2 important points you need to understand about gradient. Okay.